In section 2.3, we're going to be using values from our unit circle to help us solve problems. So this first one, we're going to construct a rain gutter. So let's say we have this piece of metal for making our rain gutter, and each of these sections is 4 inches, making our total 12 inches all the way across here. And as we bend this, we have our 4-inch segment here, and then as it hinges, let's say that we're going to make this into basically an isosceles trapezoid. So we know each of these is also going to be 4 inches here and here. And if we just think about where we bent this from, we end up with these angles here and here. And because we're saying this is going to be an isosceles trapezoid, then we would be able to say that we have our parallel line across here, which means that this angle would also be theta. We have alternate interior angles that would have to be congruent. And that also means that our segments here would always be the same. And that's going to make our right angle. So what we end up with is we have these 2 triangles. All right, and if we're going to zoom in on that, let's say we have our triangle. And so here is theta. And then we have this is 4. And let's say that we're going to call this side up here is A, and then this side is B. All right, and so that's just the triangle piece. And then we've, as far as finding the area of the triangle, we know to find the area of a triangle, we're going to take 1/2 times the base times the height. Now in this case, our base and our height are going to vary on this angle, right? So let's go back here. Let's see if we look at A, here's our angle. All right, so A is the adjacent, and then B is the opposite. So if we're going to look at that, then we could say that the cosine of theta is equal to A over 4. Multiply both sides by 4. 4 times the cosine of theta, our angle, is equal to segment A. Let's also look at segment B. The sine of theta is equal to B over 4. So multiply both sides by 4. We have 4 times the sine of theta is equal to B. So now let's go back to the area of our triangle. We could find the area then of our triangle for our base and our height based on these values of A and B. Here's A, here's B, so it'll vary based on the angle. So we would end up with our area is equal to 1/2 times base times height, so we would have 4 times the cosine of theta and 4 times the sine of theta. And we have 2 of these triangles, 1 on each side. So we're going to take that all times 2. Now the 1/2 and the 2 cancel out. So the area of those 2 triangles together, we end up with 4 times 4, that's 16, times cosine of theta times the sine of theta. That's just the triangles. We also have our rectangle. So if we look at the area of the rectangle, we know that our rectangle area is equal to base times height, and in this case our base, we're going to have 4 inches here, and then here is side B way up here, so we have 4 times B, so that's going to be 4 times, and then we already said B is equal to 4 times the sine of theta. So that gives us the area of our rectangle as 16 times the sine of theta. So if we were to put all that together, we can find the area then of our rain gutter depending on the angle. And as we change the angle, it would change the area of that rain gutter. So if we put those formulas together, we can determine the area based on our angle theta. And here is for the triangle, where we had 16 times cosine of theta times the sine of theta. And then here was the area of the rectangle, 16 times the sine of theta. So let's say that our angle is 30 degrees. We know, using our unit circle, oops, that's a 30 plus 16 times the sine of 30. We know that the cosine of 30 degrees is going to be square root of 3 over 2, and the sine of 30 degrees is 1/2. So then here we have 16 times 1/2, and here we have 16 times square root of 3 over 2 times 1/2. So then we can find an exact answer. This is going to give us 16 times square root of 3 over 4, which is 4 square root 3. Then over on this side is plus 8. And that would be our exact answer for the area when our angle is 30 degrees for that trapezoid. That's approximately 14.93. So what we're able to do then is vary the angle and see what's going to give us the greatest area. Let's see if we have our angle is 45 degrees. Again, we have 16 times the cosine of 45 times the sine of 45 plus 16 times the sine of 45 degrees. We know, again, looking at our unit circle, that cosine and sine at 45 degrees gives us square root of 2 over 2 for both of those. So here we have 16 times that value, and here we have 16 times both of them. So then we can find that the area of the trapezoid, when our angle is 45 degrees, would be equal to 8 plus 8 square root 2. That would be approximately 19.31. Of course, on both of these we're talking area, so this is going to be square inches. What if we make our angle even steeper and change it to 60 degrees? Again, we have 16 times cosine of 60 would be 1/2 times the sine of 60 we know is square root of 3 over 2. So again here 16 times square root of 3 over 2. So then this is going to be equal to 4 square root 3 plus 8 square root 3. So that gives us 12 square root 3 for our exact answer, which is approximately 20.78. That's our greatest area so far. Now, these are all values that have been on the unit circle. What if we change our angle to 75 degrees? Still, we have 16 times the cosine of 75 times the sine of 75 plus 16 times the sine of 75, and we would just plug the whole thing into our calculator, get an approximate answer of 19.45 inches squared on both of these. So then we can compare the angles and see what happens to our area as we bend the metal, which is going to give us the greatest area, move the most water in the rain gutter. Some other types of problems in section 2-3 that we could solve. Here we have some functions. F of x is sine of x and g of x is cosine of x. We also have h of x is equal to 2 times x and p of x is equal to x divided by 2. So in example A here we have f minus g, so we're subtracting the functions at 60 degrees. So if I think of f of 60 minus g of 60, that's going to be the sine of 60 degrees minus the cosine of 60 degrees. Again, using our unit circle, we know sine of 60 is square root of 3 over 2, and the cosine of 60 is 1/2. So our exact answer, square root of 3 minus 1, all over 2 for that. Here we have f of pi over 6. That's going to be sine of pi over 6, or sine of 30 degrees. And then h is 2 times x, so we're going to take that times 2. Now we know that the sine of pi over 6, or the sine of 30, is 1/2. If we take that times 2, we get that value to be 1. If we have g of pi over 6, that would be cosine pi over 6, or cosine of 30, that is square root of 3 over 2. Now let's say that we have a value where we're asked what point is on y equals 2 times g of x minus pi over 6 if we have x is equal to pi over 6. Alright, so we just solved part of that. We found if we plug in pi over 6 here minus pi over 6, we know g is cosine, so we're taking the cosine of 0. And then we're going to take 2 times that. So we have 2 times the cosine of 0. We know cosine of 0 is equal to 1. 2 times 1, so we find that y is equal to 2. So then again, our x value is pi over 6. Just found y to be 2. That would be the point.